Welcome back, folks. In today's presentation, I will give a discussion about the Hollow Earth, its origin, presence in ancient history, explain this Hollow Earth theory with modern findings, and then come to my own conclusion. Strangely, there is no origin. It just springs up from ancient history. It's all in folklore and legend about subterranean beings originating from the inner earth. Ancient accounts of a hollow earth can be found in various mythologies and folklore across different cultures, including stories from Native American tribes, European legends, and even the writings of ancient Greek philosophers, often describing a subterranean world accessed through caves or openings in the earth, sometimes inhabited by mysterious beings or ancestors of the people who believe in the myth. Very interesting indeed. The description of what the climate is like is strangely comparable to how we envision prehistoric Earth, or the antediluvian world. It's also said to be the place where spirits go in the afterlife. Christianity is no exception. Even Jesus said that after his death, he would go into the center of Earth for 3 days. Now, why is that the case? I mean, if there's nothing else but heat and hot rocks, what's down there to see? Is Hollow Earth really just some myth? Did we actually disprove this idea a long time ago with modern scientific evidence? Could there be any truth at all to the Hollow Earth theory? This brings me to the following. We've all seen it. The Earth consists of 4 layers. We know this. But how? Through waves. Now there's 2 ways to do this, S waves and P waves. Scientists use S waves to get imaging from the Earth without having to dig into the planet. It can only travel through solids, not air or liquids. So we know without a doubt that the crust, mantle, and inner core are solids. But here's the question. How do we know that there is actually liquid between the inner core and the mantle, especially if S waves cannot travel through air or liquid? This is where P waves come in. Now, P waves are much more useful in mapping out the interior of Earth. In liquids, P waves travel between 1 and 8 kilometers per second. The denser the liquid, the faster the waves travel. In solid surfaces, P waves travel fast. In air, P waves travel at the speed of sound. Now, I see what mainstream science is talking about, but my objection is that if there really was a fluid outer core, the P waves would travel much faster because the fluid is denser, but it doesn't. In fact, it actually travels slower, though you could argue that the fluid is actually not that dense. But if gravity resides in the core, wouldn't this compact the density of the liquid too? Now, am I saying that there is no outer core? Not necessarily, but the math suggests 2 possibilities. Not 1, but 2. Yes, so here are the 2 possibilities. There's either an outer core made of liquid, or there is a hollow space between the mantle and inner core. Now let me elaborate on the second part. This hollow interior is much more similar to the upper atmosphere of Earth rather than the troposphere. Yes, P waves do travel in thin air slowly. And where does the end thin out? The higher up you go. And if this is so, that easily explains why the P waves travel slowly through the outer core. Rather than traveling through liquid, it's actually traveling through a space with thin air, and we're misinterpreting it as traveling through liquids. So we have the basic model for Hollow Earth, but there's several problems. If there's life down there, how can it survive the intense heat and radiation? How can a hollow Earth produce a magnetosphere? What about gravity in the magnetic field? And finally, what about earthquakes? First question. This inner crust needs to have an atmosphere, and a very strong atmospheric structure that protects the inhabitants from the intense heat and radiation. A layer similar to the ozone layer would be needed as well, only it would need to be much, much stronger. Most of the radiation would also need to be directed to where the magnetic poles are located rather than the 360-degree radius. Most of the heat is blocked and redirected, but some of it does pass through to the inner crust. The inner crust itself has a lot of water, possibly more water than in the outer crust. This would result in humidity, a lot of humidity. There are not any oceans in this inner crust, but rivers, lakes, and seas do exist. The heat causes the water to evaporate, creating a mist canopy, cooling down the entire environment. Rain isn't needed. Instead, mist and fog is what allows the inner crust to thrive. Kind of reminds me of the antediluvian world. 3. Gravity. Gravity would not be within the core, but within the mantle. Yes, it has enough mass to keep objects attached to it, allowing for the inhabitants of both sides of the mantle to stay put. Something similar applies to heat. The mantle would be the hottest region rather than the core. Since the core is not the same distance as the sun, it doesn't need to be as hot as the sun. A much cooler core would be more suitable for sustaining life. But even if the core is much hotter, most of the heat and radiation is deflected by this inner ozone layer and directed to the magnetic poles. You basically have a cold outer crust, a very hot mantle, a cooler inner crust, and a hot radioactive core and inner space. Well, there's more than one way for earthquakes to occur, and one of them has to do with currents from the core. But this would definitely affect life inside of Hollow Earth, especially since the core is only 1,400 miles from the mantle. This would mean much more severe earthquakes in the Hollow Earth than the surface world. Well, first, there needs to be a means for protection against the extra heat and radiation from the core. Remember what I said about the inner ozone layer? Only a small amount of heat and radiation would make it to the inner crust and pass through the mantle. Now, since the mantle has a lot of heat and radiation, the radiation from the core pushes the radiation out from the mantle to the outer crust. If enough radiation comes through, this results in sudden plate movements, creating earthquakes and volcanism. So, with all of these things, a hollow earth is not as scientific fiction as we make it out. Folks, when it comes to topics like this, we really need to make an effort to not let fantasy and science fiction cloud our understanding. So, in the end, we know that a 500 to 1,500 mile thick hollow earth with 100-mile diameter holes at the poles has been thoroughly debunked. But no, the possibility of a hollow earth still stands. A scientifically accurate hollow earth would be much closer to this. Now, this is where some of you would say I'm making an unfalsifiable claim. Well, that's kind of good in a way. This means that this idea can work, and it should be accepted among the other possible models for Earth in mainstream science. But it's not for some reason. Why? The only thing getting in the way is a refusal to rewrite science. And since they already have a theory that is popular among mainstream science, why introduce another theory that works? Apparently, they only want to have one idea hailed. Everything else is secondary. And if mainstream science were to adapt a hollow earth worldview rather than the current model, this would bring us much closer to ancient history and religion, and thus closer to the truth. But we know that mainstream scientists will never do this. They need to make every effort to separate natural sciences from the equation of ancient history and religion. They have to, especially now since any attempt to go back will be met with major public backlash and resistance. All in the name of science? More like all in the name of self-interest, popularity, and anti-supernaturalism.